Emerald podcast series. Research that makes a difference.
Hi, I'm Rebecca Torr, and welcome to the Emerald podcast series. In today's episode, we're exploring the world of aging infrastructure in cities, with a particular focus on bridge infrastructure. Our guest is Dr Stergios Mitoulis, Associate Professor and Head of Structures at the University of Birmingham, and Editor-in-Chief of the Journal of Bridge Engineering. We'll be discussing the sustainability and resilience of bridges, the role of smart city initiatives, advancements in sensor technology and AI, and much more. Join us as we explore the challenges and opportunities in maintaining and upgrading our vital bridge infrastructure.
Thank you very much, and thanks for the invitation. So, yes, many bridges designed for cities and urban environments, they were actually built decades ago, and mainly in the 60s and the 70s. And thus, they're currently reaching or have surpassed their intended lifespans. And that leads, obviously, to widespread aging issues. All sorts of problems are now accumulating. So there is key challenges, and that includes structural deterioration, corrosion, material fatigue, which threaten safety and require frequent inspections and repairs. It is not only the deterioration of the materials and the bridges and the impact of climate change on the infrastructure. At the same time, bridges and also other infrastructure in our cities and urban environments, they're faced with increased loads and increased demands. For example, the lorries are becoming heavier, the traffic volumes become greater, and at the same time, climate exacerbates hazards such as floods and sea level rise. So all these deteriorated bridges, they also have to face extreme events, extreme threats and stressors, and hence we need to make sure that we proactively strengthen our bridges to avoid failures and disruption in our urban systems.
I think it's really interesting, and most of us, we go over bridges quite frequently. They connect one piece of land to another, but how important are bridges, and how does that contribute to sustainability and the Sustainable Development Goals? I mean, I was just wondering sort of how they could be designed or upgraded to further support sustainable development.
Yes, thank you for the question. This is a very interesting question. And that brings into my mind an advert of a construction company back in the day that was constructing a bridge along a major highway. There was a big sign at the entrance of the bridge saying bridges connecting people. And I think that's what it is. Bridges are the structures that minimize the times of commute, help people to go to their jobs and their loved ones faster and safer, and help us cross rivers, valleys, and other natural obstacles that would be impossible to do otherwise. So, yes, bridges are contributors to sustainability, and looking at more tangible sustainable development goal based performance indicators, we know that bridges enable efficient transportation and connectivity. And if you have a bridge that is closed, that increases the travel time and the distances and the CO2 emissions that we emit to the environment. So bridges reduce CO2 overall. They are also designed as robust joints within our transportation networks, and hence they enhance climate resilience by making our cities and infrastructure more resilient and more robust against climate change. For example, imagine a network that is being disrupted because a bridge is closed. Obviously, the network will become less resilient, whereas if you have more bridges in place and hence more alternatives to go from A to B, then automatically your system becomes more resilient and hence more sustainable.
I think that's really interesting. And when we talk about smart sustainability, we often talk about smart technologies. And obviously, there's been loads and loads of changes recently in terms of how smart technologies can help us build better. And it's often connected like that something smarter is often better and more sustainable. And that might not be the case. Just because it's a new technology doesn't necessarily mean it's sustainable. But I just wondered, from your perspective, how you see sort of those initiatives, those sort of like those new technologies, and how they intersect with bridge infrastructure, and what role really do smart bridges play in the overall vision of smarter urban environments? Are smart bridges better?
That's a very interesting question, actually. I'm a fan of technology. I love technology. I love data. I love the new era of artificial intelligence and monitoring and use of satellite imagery for managing and operating infrastructure. So I think in the concept of a smart city and the initiatives around smart cities, we do need to prioritize data-driven infrastructure, and that includes bridges, smart bridges, where sensors are installed, and these sensors are part of an Internet of Things technology to provide, for example, real-time monitoring, real-time data and information to the end users, to the drivers, and also predictive maintenance inside. So it's not only about the end users, but it's also about how managers operate, how managers make decisions for strengthening and adapting bridges to climate change. So the way I imagine it, and the way it's happening now, actually, but it's at the very early stages of R&D, that smart bridges, they can enhance urban resilience by enabling, for example, I'm just going to give a couple of examples, automated response to natural, climatic, and human-induced threats and stressors. Imagine you have a bridge that has a heavy traffic, or an earthquake that strikes the bridge, or extreme temperatures. This is the kind of threats that inflict changes to our infrastructure and to our bridges. And these systems, these sensing technologies, they can give us this information so that we can make decisions very quickly as to whether the bridge is safe. And there is also um, a great area there and a great opportunity to strengthen a more sustainable future, to support a more sustainable future by optimizing, for example, traffic flows and reducing congestion and emissions. So yes, we live in times where infrastructure is strongly interconnected, and there is strong interdependencies between our infrastructure, our hard infrastructure, and our soft infrastructure. Imagine the data in the ICT systems. And so we need to look into our systems from a cyber physical point of view, which means that cyber systems and physical systems, they all shape the world as we know it, the cities as we know them these days. These systems are said to be more complex, but at the same time potentially more resilient, because they give us more opportunity to react and make decisions quickly. So when you have, for example, an alert from sensors, you can very quickly give an early warning to people so that they don't use the bridge, and hence reduce the risk of accidents or reduce the risk of fatalities. But at the same time, technology also comes with um, some challenges, and the challenges are, okay, how do we operate our bridges by using these huge volumes of data of multiple sensors? How do we integrate data from different sources, from cameras, from thermometers, from devices that measure displacements in traffic? So there's also always a challenge there, and of course a great area for research.
I think it's a really exciting time, isn't it, to be in this area of research, and to see how those smart initiatives and those smart technologies are really can make a difference. And as we all know, we've for the last few years, we've all been very much talking about artificial intelligence, and sort of the role that AI can play in, whether it's in our everyday lives, or it's we look at construction and infrastructure, sort of the role it can play there. And obviously, you were talking there about sort of understanding what's going on in real time. And I just wondered what AI and sensor technologies can do to help us monitor the health of aging bridges. And are they effective? I mean, perhaps it's early days yet, but do you think they will help us extend the life of bridges? Is that something that's possible?
Yes, I certainly believe so. And not only, there is a lot of opportunity out there with the use of AI, data technology, data mining, and so forth. So I'm just going to give some examples because AI and bridge management or infrastructure management, if you like, have only met very recently in the domain of infrastructure management. So imagine you have sensors that can detect stresses, vibrations, temperature, traffic, corrosion almost in real time. And that would allow you to continuously monitor the health of your bridge. Now, an AI algorithm or a machine learning algorithm or a deep learning algorithm, all being under the same umbrella of artificial intelligence, is that it can very quickly, rapidly, almost real time process data. And that means that you can now bypass the, let's say, analysis stage where you need to analyze the entire bridge, from A to Z to find out what might be, a plausible scenario or a potential outcome from that. So, in simple words, even though AI is, we consider it as a black box these days, and we try to make sure that we make it explainable, at the same time, it accelerates the decision making and the outputs in our bridges, meaning that we can make decisions very quickly, very efficiently, with very high accuracy. And AI can also help us build meta models and bypass the need to analyze, for example, use finite element software to analyze bridges. Most of the bridge engineers, traditional bridge engineering has been using finite element modeling. Now, these days we know that to some extent, this can be bypassed. So these technologies have been proven to be very effective in extending its lifespans, making decisions, and enabling timely interventions. And it is really a fascinating area around these technologies. However, we always need to be cautious, and we always have to have the engineering angle to our problems. Okay, so whenever we get results from AI, or we get a warning or a decision based entirely on AI analysis, I would suggest use your engineering feeling, use your engineering sense, your feel for the structure, and make sure that the results are interpretable, explainable, and you can actually justify where these results are coming from.
I think that's excellent advice because, I mean, all of us have probably experienced, if you've ever used, some of these, like ChatGPT, some of the results that come back, can be fabricated or, I know there's a lot better technologies out there and but that's just on an everyday level of experience that it's not necessarily completely accurate. So it's interesting to hear you explain that this is not the answer. We need our expertise. We need the people that understand how bridges work, from a structural point of view, physically, not just the intelligence. But yeah, I mean, I guess, that sort of brings me on to some of the other challenges around smart technologies for bridges. Smart technologies are very costly, and we do have the capability with these new technologies to do great things. But barriers are what prevents us from sort of just skipping ahead and making everything smart. And perhaps there are barriers related to costs and training, and even public perception. Perhaps what I've just described about, is it safe, or is it accurate? Are we going in the right direction? So yeah, maybe you can just sort of talk us through the challenges around implementing smart technologies.
Yes, thank you for the question. This is actually a question that I've been asking myself and, all the researchers in my research group around the cost of these technologies. Is it feasible? Is it justifiable to use this technology? So yes, on the one hand, there is high initial cost for installing sensors and developing data management systems that can limit, this can limit the adoption of these systems, especially in cities with budget constraints. Managers always deal with budget constraints, so we always need to bear that in mind. So implementing and maintaining these technologies requires at the same time not only investment, financial investment, but also specialized knowledge and training. So you need the people, the right people in place to, process this data and make decisions based on data. So at the same time, there is public perception with issues that may arise around privacy, and some communities are also, worry about potential disruptions. They, concerns about, as I said, around privacy with smart infrastructure. But at the same time, I have to remind, all those people who challenge digital technologies, the fact that digital technologies could have given us warning in many occasions and avoid, disruptive events, such as, for example, the failure of the Polsevera, or also known as the Morandi Bridge in Padova, Italy, that took the lives of 43 people, or the failure of the Carola Bridge very recently in Dresden, Germany, and the collapse of, another example, the Francis Scott Key Bridge in Baltimore that costs billions and billions of dollars. So I believe using and leveraging data and use it for the right purpose, that it can actually save lives. One of my concerns when I'm using data and these technologies is, how do I federate this data? And as I mentioned before, how do I interpret this data, all these results that we get from AI in milliseconds of time? How do we trust this result? And I think the answer here is to, train a good bridge engineer, train, good engineers so that they have an understanding of that, and they know what to expect from their structure, so that they don't, you know, fully rely on AI results, but rather, also rely on their engineering instinct.
I think that's really excellent advice, and I mean, I think we're still quite early days, aren't we, in what we can achieve, just by relying on AI and other technologies purely on their own. I hopefully it will always be a human interaction with them, and I guess we've looked at smart technologies now. I guess the other key thing is policy. It could be in relation to should there be policy related to sort of data, smart technologies and data, and security and things like that. But yeah, I just wonder from your point of view if there was any particular policies that should be implemented to enhance infrastructure resilience, especially in relation to aging bridges. And I don't know if you've seen any gaps, because you've mentioned a few cases there where probably those bridges should have been maintained, or something should have happened. Perhaps you've seen it in your research and witnessed where policy could have made a difference. And what can we do now? And we can't help what's happened now, but what can we do looking forward? What can policymakers do? What should they be paying attention to?
Yes, thank you for the question. That's an interesting one, because that goes well beyond my engineering expertise. That's about policy. However, engineers are also responsible for policy making and standardization, which means that we develop the next generation of design guidelines for designing bridges, for example. So yes, one thing that comes to my mind is that there is no good structure without good policy in place, and that applies to any kind of infrastructure asset, any critical infrastructure, any urban environment, any build ecosystem. So cities should adopt policies that mandate regular, for example, bridge inspections, and prioritize preventive maintenance, and allocate dedicated funding for infrastructure resilience. Now, the question here is how quickly we can, put legislation in place and put policy in place to actually require that from the engineers and from the governments. How quickly can we make decisions to convince governments to allocate more funding for preventive or proactive, if you like, adaptation measures for bridges that can help us design rational interventions and bolster bridges against emerging threats of climate change, for example? Because we know that being reactive in case of hazards, for example, strengthening bridges after a flood happens, after a fire happens, is not as efficient as being proactive. And at the same time, doing things in a proactive way will also save a lot of CO2 emissions, and we will do things, by taking our time and designing appropriately structures and so on and so forth. So the question here is how much policy we need, how quickly we need this policy. In my opinion, we need this policy as soon as possible. And last but not least, how much funding can we allocate in the near future to bolster, to strengthen our bridges proactively?
Thank you very much. I mean, it's the hot topics around sort of climate change and how extreme weather is affecting, our lives and our cities and our infrastructure. And I think, it makes sense that right now is the time to pay attention to the funding and the policies that will address these issues, because they're not going to stop. They're not, the climate change is happening, and it's happening at pace, and it is impacting the way we live. It's impacting our infrastructure, and it makes sense that now is the time. If we've never done it before, as much as we should have, we should do it now. And I guess it will be quite interesting from your perspective how you see climate change impacting our cities, our urban environments. I mean, what do you think are in the near to long term consequences of climate change? What do we need to be doing to address this? Because obviously bridges are being affected quite dramatically, as you've described.
Yes, that's correct. So bridges are affected by climate change in a very dramatic way, and we have seen that over the years, with bridges failing more and more frequently over the last, I would say, 5 to 10 years. And that is not only the accumulation of deterioration of the materials; it's also climate change, obviously. So climate change, at least from the side of bridges, has increased dramatically the frequency of extreme weather events, such as flooding, for example, and hurricanes and heat waves. We have seen extreme temperatures a couple of years ago in the UK. And these accelerate, obviously, the deterioration of the materials. The materials lose their strength gradually. At the same time, we also have seen a shift in the way bridges respond to certain hazards. And that's because, for example, foundations are scoured. Scour is an effect of flooding. So the soil is removed around the foundations. The piers are becoming more flexible and hence more vulnerable to floods. So yes, flooding and erosion as a result of climate change, especially in coastal and riverine areas, compromise bridge foundations, and they pose, high risk to both the stability and the safety of the bridges. So these are some examples of bridge deterioration. Of course, we also know that extreme precipitation and more frequent precipitation leads to faster, corrosion of the reinforcements. The reinforcements, the pre-stressing steel inside the concrete of bridges becomes rusty very quickly. And this is alarming, obviously, and especially for bridges, because bridges are delicate structures. We don't have them in our minds as being delicate structures, but they're much more vulnerable and much more fragile than common buildings. And that's because they have great lengths, they have less supports, less columns than the building, which means that small changes in their structural system can lead to collapses. And in fact, the very recent failures have actually proven that point, that bridges are very vulnerable, very fragile to climate change.
Yeah, it's so interesting, isn't it? And you mentioned, sort of in the last 5 to 10 years, we're seeing the impacts specifically, intensifying because of climate change and, more and more bridge failures. And I mean, this isn't going away. So are there any specific technologies, that we can take advantage, or new materials that really are going to help us to adapt our existing structures to future climate change challenges? Is there something that we can do to fast track that? I'm guessing it's going to be quite expensive.
Yeah, interesting point. They're not that expensive. I mean, yes, they might be slightly more expensive than the traditional concrete and steel, but it's not out of proportion in terms of costs. So yes, there's been a lot of R&D, research and development around new materials with high strength concrete, high strength steel, and fiber reinforced polymers. Corrosion resistant steel, and all sorts of materials that we use for strengthening our bridges. This is, I would say, the very much like asset specific traditional methods for strengthening our structures. And these are not very different from the ones that we're using for buildings, for example. Might be the scale slightly different, but overall, I would say these traditional methods could be applied for buildings, could be applied for any kind of infrastructure asset. But for bridges, there is also advanced protective measures um, for combating climate stressors. So, for example, specialized coating and waterproofing techniques to help protect against corrosion and damage from flooding and salt water. There is also, if we look at larger scale um, infrastructure measures, we're looking at cities that implement climate adaptive design, such as elevated structures and resilient foundations to mitigate risks from extreme weather events. So there is technology in place with a lot of focus on materials and traditional techniques, but there is also emerging technologies, emerging materials, and emerging ideas, if you like. There is a lot of space here for innovation. And if someone looks at the international literature, they will be able to spot some very, very new research and R&D around, flood resistance and flood strengthening of bridges. However, we do need to remember that it's more efficient and more cost effective in most of the cases to take some measures and adapt our bridges proactively. So before something happens, we know today that climate changes. If we don't do something today, and a flood happens or extreme temperature impacts our bridges, we will have to pay much more to strengthen our bridges, and we will do that in not in the best way, if you like, which means that we will spend more money, more effort, and we will develop something, we will design and construct something that will be less sustainable than any proactive measure.
So the time to act is now, basically. And I just wonder if I could shift gears slightly, because now that we have you here, and you are the editor-in-chief of the Journal of Bridge Engineering, I wondered, because obviously you're immersed in this area, specifically about bridges, what sort of emerging topics or trends are you starting to see come through? Are you excited about researchers exploring? And I was also wondering about, there's always sort of like a connection now to sort of the impacts of anything, to do with infrastructure, sort of the social implications. And I just wondered, you might want to touch on, have you seen much research in the area of sort of fostering social and environmental resilience potentially? And then I guess, how does the journal support and shape the future of bridge engineering also, through its publications?
Yes, it's an exciting era, right? So we're going through the times where resilience and sustainability are in the epicenter of infrastructure assessments and design, as well as digitalization, the way we use data and advanced technology. So yes, when I assumed my role as editor-in-chief of the Journal of Bridge Engineering this year, my first editorial was titled "Bridge Engineering: What Next?" And I believe this describe, in my opinion, the future of bridge engineering from the lenses of not only the traditional consultant bridge engineer, but also much more from a multidisciplinary angle, where bridges underpin the new philosophies of resilience and sustainability of structures and urban environments. And they also leverage digital technology such as Internet of Things and digital twins for more efficient designs, operation, and maintenance. And the way this is a way to integrate them into our complex urban systems. So emerging topics around bridges, these are, areas where we marry bridge engineering with emerging topics around satellite imagery, UAV enabled digital twins, digitalization, and also focus on methods for bolstering new and existing bridges to climate emergency, natural and human-induced threats. So apart from the deployment of technologies, which is I would say, the technological bridge engineering side of things, we also have bridges that serve humanity, where bridges are the epicenter of, human engineering, and they serve as enablers of equality and diversity and help ending poverty. So I do believe that bridges are, in the epicenter of critical of the critical infrastructure ecosystems, both in urban environments and outside cities. And I believe the Journal of Bridge Engineering is doing a fantastic work at the moment in attracting cutting edge research around these topics and fostering cross disciplinary collaboration, helping shaping, we're shaping the future of bridge engineering. At the same time, we're very proud that we also attract high quality papers from practitioners and designers and, bridge engineers and consultants. So we are right in the epicenter of, traditional slash, I would say, future bridge engineering from that point of view. And we would really like to see bridges transforming our urban environments and critical infrastructure.
Oh, it's fascinating, and it's a really exciting time to be an editor in this area, and to see and to encourage research in these different fields. And I think inevitably, more, I know from an Emerald perspective, we want to link all our research to sustainable development goals, and so seeing more research come through and seeing how it impacts sustainability and the issues around resilience. I think for us it's definitely something we support, and we're excited to see that, and and promote and encourage research around those areas. What would be your ideal scenario for bridge infrastructure in the next 20 to 30 years? What's your dream scenario? How would it look for you? And what really can we do in terms of balancing the current challenges of this with our structures that we've got, while building new resilient ones, because inevitably we will, as a globe, be building, because our populations are expanding. So, what does the future have in store?
So yeah, that's an interesting question, isn't it? Thinking about all the challenges of our world, urbanization, thinking about climate change, and what is the role of bridges in all that, and how bridges will leverage solutions and will help humanity to grow. So for me, the ideal scenario for bridges would be to, see all bridges designed and maintained, having always in mind the resilience of our cities and our critical infrastructure, the sustainability of our cities, of our urban environments, but also, the sustainability of our communities. So building bridges to enhance the climate resilience of our communities, to help us grow, and also bridges that will help us reduce inequalities. And also bridges that embrace smart technology and integrate data, AI, and digital twins, being at the epicenter of future research. I think balancing upgrades of bridges with new construction is also an area that I would like to see a lot in the future, and I'm sure there's going to be a lot of research, R&D, and construction in the near future. And of course, the way we prioritize reconstruction or prioritize, adaptation of our bridges, try to choose the most vulnerable structures, the most vulnerable bridges in our complex build ecosystems is also very, very important. So not only thinking about bridges from a bottom up, a perspective where, you select the materials, you select the design, and you just, design the bridges based on current design guidelines, but rather understanding and conceiving bridge designs using a top-down approach where bridge plays a very vital, a very key role into our communities, into our cities. I think that will be that will be the basis of our design in the future. So I would say, a systems perspective for designing our bridges. We also need to remember that bridges are connecting people. Okay, so they also underpin our economies, our communities, and are part of our heritage and culture. And hence, we have a duty to preserve our bridges and make them stronger, but also accessible to all.
Thank you for joining us on this episode of the Emerald podcast series. We hope you found our discussion on ageing infrastructure and bridge resilience insightful and thought-provoking. A big thank you to Dr Stergios Mitoulis for sharing his expertise and knowledge with us. You can find more information and a transcript of the episode on our website. A final thanks goes to podcast producer Daniel Ridge and the studio This is Distorted. This is Rebecca Torr signing off. See you next time.